So welcome everybody to the Module 4 webinar for Euclid, where we'll be talking about interaction with linked data. Today we have a guest presenter for half the presentation, which is Michael from Fluid Ops. I'm just going to run through the introduction and then hand over to Michael, and then I will come back for the second half of the webinar as normal after a short break. So in terms of the motivating example that we use in Euclid, today's material fits here and here, sort of top-level presentation. So how do we present some of the results that we obtain using linked data to an audience, and how do we allow a degree of interaction with that in order to build a useful, compelling application? As a bit of a reminder where we've been so far, we're talking about the technologies that you could pull together to build some sort of data-driven portal in the music domain, and we introduced that idea back in Chapter 1. So far, Chapter 2 has rather concentrated right down at the data level of how we could do queries and updates over this kind of data. And then Chapter 3 got into how we could take other sources into linked data to bring them into those capabilities, how we could offer linked data out through RDFA interface, in the interface, through dumps, and also how we would register the data sets that we build in repositories. All of these are oriented really towards machine-readable data. So we might see something like here, RDF in XML, something that no human was ever destined to read. Here, cleaned up a little bit, the turtle syntax for RDF, which data experts can read, but by far you wouldn't want to present to an end user. Similarly, when we talked about querying in Chapter 2, here are a set of query results, Sparkle results in XML, and similarly for a certain audience, we might rather offer Sparkle results in JSON, so a front-end developer working in a scripting language, JavaScript or anything else that has a JSON library, might be happier with that, but there's still a good distance to go before we could present, albeit interesting data like this, to a user, and that's going to be the focus of today's webinar. So the first part today is going to concentrate on visualization techniques, which Michael will walk you through. As an overall example, we might start with some sort of search box entry point into a system. But what we're aiming to do is present them with a rich experience like this, where we tie together text and media, where we tie together visualizations like the one we see over there in terms of maps, in terms of charts, to give people an idea what's in the data without reading those ugly formats. Visualization in general is going to let us tell a story through our data. It's going to help people understand the data in terms of the pattern matching capabilities that humans have rather than data parsing capabilities that computers possess. It's also going to let us bring out certain characteristics in our data which might not be immediately obvious even with access to the raw data. So there's an example down here of patterns that we can bring out between data sets that appear very different but share certain things in common. So again, the agenda for today, first thing is visualization, then we'll talk in a little bit more depth about what search means in this space, and then we'll present some methods for linked data analysis that can feed visualization and feed user experience. So with that, for the first part, I'd pass over to Michael.
Thank you, Barry. So welcome also from my side. As Barry already pointed out, I'm going to cover the part on linked data visualization. And when we talk about visualization or linked data visualization especially, we refer to graphical representations of a certain region of interest within a data set. Yeah. And this graphical representation or visualization we will have to choose according to the type of data that we want to visualize and, of course, according to the purpose that we want to achieve with our visualization. The process of visualizing data can be imagined as followed. Imagine at the very top you have the raw RDF data. From that raw data, you extract your region of interest. This may be done, for example, with the help of a SPARQL query. Given the extracted data, you apply certain forms of transformation such that in the end, some visualization tool can take the data and directly visualize it. And then, very importantly, we're not finished, but guided by the visualization that the user sees, he can then start really interacting with the data. So, so that means browsing to a special data item of interest for him, or maybe even modifying the data. Let's go to a concrete example. So say that you're interested in visualizing Beatles releases, countries, countries where the Beatles released their records. We have our music brains data set loaded in our triple store, and with the help of a SPARQL query that may look like this, we extract a relevant region of interest from that data set. In order to be able to fit that in the visualization module itself, we may apply some visualization, some transformations as already outlined. So in this case, country names are encoded by country codes. So United Kingdom is encoded as GB and so on and so forth. And in this example, this may be then a suitable input format for our visualization toolkit. Of course, we have to tell the visualization toolkit a little bit which one of these two columns is the country and which one is the number to be displayed. So there needs to be some additional information at this point. But once we have that, we can get something like this. So let's talk a little bit about the challenges of linked data visualization. Very important point that I already talked about a little bit is the point of user interaction. So we really do not stop at seeing this nice little picture here, but a graphical representation of the data should really facilitate user interaction with the data. That may mean browsing to a more specific region of interest. That may mean editing the data in case there are errors in the data, missing values, and those things. Ideally, the output of such a visualization is encoded in such a way that it is reusable for other people. So the output itself, or that the process encoded, the process of getting to this visualization result encoded in some kind of open standard. And of course, as always, scalability is a big issue because, of course, we are also interested in visualizing the results of, for example, very challenging SPARQL queries. So, so much about linked data in general. When we add to linked data the dimension of open data, there come a lot of much more challenging topics into play. For example, the data, your region of interest in the data may be spread across several data sets, several repositories. You may have very heterogeneous data in the sense that your region of interest is formulated in many different vocabularies. Several data formats may be used, for example, several formats for dates or timestamps in general. You may have missing values and such things. In general, we can classify visualization techniques into several categories. For example, if your task is to compare certain values, attributes, you may use bar chart, pie chart, line chart, histogram. If you are interested in analyzing relationships between certain entities in your data, you may use a graph, arc diagrams, matrices, and other techniques. If you're interested in analyzing temporal or geographical behavior, you may use timelines, maps, and in case you want, for example, analyze multidimensional data, you may, for example, in the case of three-dimensional data, use scatter plots, or in the case of higher dimensional data, parallel coordinates or radar charts. This is only a rough overview. We're going to cover many examples for the different categories of visualizations in the following. So, comparing values. So, say if you're interested in the absolute sizes of a value, you may use a bar chart. If you're interested in percentages, relative values, you may use a pie chart. If you're interested in, for example, showing the result of a query along an axis, you may use a line chart. And if you're interested in the distribution of the data over certain values, there's always the possibility of a histogram. Analyzing relationships and even more special hierarchies. You can, of course, use a standard graph representation, like depicted in this picture here, or a little bit more specialized in the form of an arc diagram, where you basically draw all the nodes in your graph on one line, and then the edges between two nodes are displayed as circles connecting these two nodes. You may use an adjacency matrix, where basically your nodes are displayed as an X and a Y axis, and the edges are displayed as entries in your matrix. And there are, of course, other forms, especially tailored to visualizing hierarchies, trees, like, for example, the node link visualizations. A whole range of techniques related to visualizing hierarchies is related to so-called space filling techniques. That means somehow you fill a certain amount of space with the data you want to visualize. For example, the tree map, where you, for example, say, you want to visualize the amount of instances of your classes in your data sets. That means compare the number of music artists against the number of creative writers in your data set, and so on and so forth. So the idea is then to divide a rectangle according, for example, to the number of instances in that class, and divide the rectangles that you obtain for every subclass that you also want to visualize in the chart. And then what you get is basically a kind of plastering of the rectangle. There are also variations of that. For example, icicles and the sunburst, shown here at the right side. There's also the circle packing technique, directly showing containment of entities to be visualized in circles. Yeah. For the category of analysis of temporal or geographical data, we have variations of timelines. For example, here a timeline with discrete points in time, or here timelines with continuous data shown here. And of course, for the category of maps, there are also several options available, like for example, using markers on a standard Google Map API, or showing a chloropleth map, basically the same that we've shown some slides before, or, well, if the borders of a certain country do not really matter to you, you may also substitute the country borders in the map by circles and then end up in a representation like this. Concerning multidimensional data, or especially here in the first case, the scatterplot three-dimensional data, you have an x and a y-axis, two-dimension, and basically the third dimension is represented by the radius of a circle here. So representing the three possible dimensions of a data point two-dimensionally. If your data that you want to visualize is higher dimensional, there are also further options available, like for example, the radar chart, where your different dimensions correspond to axes in this chart here. So, and quite similar, I would say, the parallel coordinates, where your dimensions correspond to these parallel lines. And then one point in your high dimensional space is then represented as a polyline connecting the appropriate values on the axis. So, basically to sum up, to finish the short overview about representation techniques, possibilities, we have a tag cloud here. For example, here on the left side, a tag cloud on DBpedia music genres, where the size, basically, of a music genre in this representation here corresponds to the number of entities found in the dataset for this genre. And there are many variations of tag clouds, one shown here on the right side. Just to give some examples. So having all these many possibilities of visualizing data, graphically representing data, what are the applications of it? Well, very generally stated, visualizations are extremely useful when you want to get a quick overview of something. For example, an analysis result. You can, in a graphical, human beings can, when represented in the graphical form, much more easily analyze the data being there. For example, an example for such an analysis may be what relevant classes are there in the data set. Are there any characteristics that I can, for example, see in my bar chart or my pie chart? Or even is there something missing? Which I could, for example, easily see in a graph representation of a data. Given, for example, certain entities in my data set, how are they connected to each other? Do I find any new paths, or do I perfectly know how they are related in the data set? And of course, visualizations help to find errors or atypical values, which then can be corrected manually or, depending on your application, even in a semi-automatic way. What are concrete requirements for tools that do linked data or linked open data visualization? As already pointed out, they should allow for some kind of exploration, navigation in the data. So not just step at the visualization itself, but allow people to go further in the data. So navigate, explore through the data, exploit data structures that you have, allow for user interactions. So for example, if I have a large result table, allow the user to filter down to specific values and in certain sense allow him to narrow down his region of interest until he's really found what he needs. And of course, this should be really an interactive process. So big requirement on the user interface of a linked data visualization tool is definitely the interactive user interface. So there must be some responses to requests from the user. And ideally, a graphical representation should be publishable in some way. That may mean that I can publish the underlying data from which I generated the visualization, or ideally, I would be able to publish the visualization itself. So in the literature, or in the web out there, there are different categories of tools that allow for linked data visualization, which we are going to go through now. So at the beginning, there are linked data browsers with only a text-based representation. So basically what they do is that they dereference URIs and display textually all information, that means all RDF data that they find for that given URI. They display adequately the text and also the images, so that means images are really recognized as images and not as a binary object. And well, their main purpose is that they kind of support this explorative process of going through the data. So being on the page for a certain entity, you can click on a data item of interest for you, go to the page for that entity, and kind of navigate through the data. But as already, as the name already says, this is limited to a text-based representation only. There's no real graphical analysis involved. Then there's a second category, linked data browsers and RDF browsers with some visualization options. So these are basically browsers which allow graphical representations to a certain degree. They are visualization toolkits, which basically extend the degree of visualization options that are available in the system. And the fourth category are the tools for sparkle visualizations, where basically you have all kinds of options available to graphically represent sparkle query results, and where you can really customize all visualizations according to a sparkle query. Yeah, there are a lot of tools out there that fall into these categories. Of course, in this webinar here, we are only able to cover a few of them. So in the following, we are going to talk about data browsers with text-based representation, Sigma and Syndice. And after that, we're going to talk about the FluidOps information workbench. So starting with Sigma. So text-based representation of RDF data. Usually, so you start in the system by issuing a keyword search. For example, in this case here, you're searching for the Beatles. And well, in the end, you will get something like a text-based representation of all triples that are available in the system for the URI of the Beatles. So basically, what the page displays here is for every predicate, for every outgoing statements from the Beatles, every predicate, it lists all values, so all objects of this predicate in a kind of clustered manner. What is special to Sigma is it also shows here, it's in tiny gray here, besides this picture, the provenance, so the origin of this specific data item. So in this case of this Beatles picture here, the provenance is under reference 15. And all the possible references are displayed here on the right side. So each of the items that you see in this list here is basically a data source that contributes information to the textual representation here on the middle of the page. And as you can see, the page here is composed of many data sources that contribute to that representation. A text-based RDF browser certainly has its strength when it comes to getting a raw overview of the properties available in your data set. So you can quite easily see, for example, property artist is available, property after, property whatever. But of course, it is also the disadvantage, the big disadvantage, that for every properties, it lists every entry. And these may be available in many different languages and so on. So you may end up with a lot of information, for example, for the predicate année here, which may be not intuitively clear to a user what it actually means. Another example for such a text-based RDF browser is Syndice. The general idea is pretty much the same. You may start using the system by issuing a keyword search. You get a certain set of results, so URIs that may or may not correspond to the keyword search that you issued. And in difference to Sigma, you have to the ability to narrow down the result set a little bit. So you may, for example, specify the format that you only want data available in a specific format, or that you only want results which belong to a certain class in your data set. And so that gives you kind of basic filtering capabilities. When you then go to the page of a given result item, you get basically a similar representation like in the Sigma case. So in this case here for our search item, the Beatles, basically all the outgoing statements are listed that are available in the system. Then concerning tools that do Sparkle visualization, we talk a little bit about the information workbench. We have built, especially for the Euclid project, a demo system, http musicbrains.fluidops.net. It is publicly available, and basically you can see all the visualizations, all the stuff that we've created for the Euclid project on this demo system. So check it out, yeah. Now I'm going to talk a little bit about the capabilities of the information workbench when it comes to visualization. Yeah. We support a lot of visualization techniques, bar charts, pie charts, Google Maps, timelines, whatever you want to have. And well, the important thing is that we plot results from Sparkle queries. So nearly every graphical representation of data items that you see inside the information workbench comes from the result of a Sparkle query. And having a graphical representation, we do not stop there. The visualizations that we use also allow for interacting with the data in an explorative manner. So for example, you may start using the system on the front page with a full text search here, so searching for the Beatles. And I mean, it's the usual story. You end up with the query results containing everything you do not want to have. So issuing a keyword search like the Beatles, I mean, most people expect only music artists in their result and not releases or tracks, just music artists. This is exactly the reason why we have, I mean, besides the full text search, also implemented an artist search where we really can be sure that we only get instances of music artists as result. And as you can see, the result in this case is quite small, so it's not thousands of results. It's quite an amount of results that you can really deal with. Yeah, we've also implemented even more structured search than searching only for artists. For example, the system has capabilities of searching for artists that are located in a specific country. And you could even extend this by searching for music artists from a certain country that have a band member of a certain name. So search in the system is highly configurable, but in the end, it's all Sparkle queries. So all of these queries are in the end translated to some Sparkle, which is then issued against the data store. So having searched for the Beatles, we go to their page, and yeah, basically at the top of the page you see certain mashups with web services. For example, mashups with Twitter, showing information about the Beatles on Twitter, a Google map with their country of origin, a mashup here with Last.fm data, and YouTube here. And going more down towards the bottom of the page, we also have, I would say, yeah, real visualizations. So for example, here we have a table showing Beatles releases, their number of tracks, and their total playtime in minutes. We have a Google map showing countries where their releases were published. We have a timeline with all their releases, and we have a bar chart of the most popular records. And to point this out once more, user interaction is very important. So for example, if we have this tech cloud showing all UK music artists and the number of releases, and we are interested in, for example, Eric Clapton here, we can directly click on that data item and then end up on Eric Clapton's page, where we can go on exploring the data set and, well, satisfy our information needs. So all these visualizations, these Sparkle visualizations that you see, are implemented as widgets. What they all do is they retrieve the specific region of interest in your data via some Sparkle query. Then the user has to select an appropriate visualization technique, maybe add some configuration parameters if it's necessary, and that's it. Then you have finished doing your visualization. So what does it look like? For example, we have a query like, give me the top 10 of Beatles releases according to the sum of their track durations in minutes. Then you have to translate that into a Sparkle query, something like this. And yeah, you get some result set. Yeah. Yeah, in the case of a simple table result, this works straightforward. There are no further configurations that you have to apply. But for example, if we want to have a bar chart, we must tell the system basically which is the x-axis and which is the y-axis. And there is, yeah, this so-called widget configuration, which you can write either by hand, or we also have UI support in the system to facilitate writing such a kind of expression. But what you basically can see is at the very top we specify the bar chart. Then here in this part we basically have the Sparkle query. And at the bottom you have further configuration options, like for example, we say which of the output variables from the query gets on the x-axis and which output variable gets on the y-axis. Then we specify additional things like the dimensions of the widgets. We may specify colors and so things. And well, the bottom line is that everything you have to do to get to this picture here is writing mostly a Spark query plus some configurations. And of course, using nearly the same configurations, you can easily get, for example, a line chart, pie chart, if that suits the specific needs of the visualization that you want to have. The system also has capabilities of suggesting a type of visualization. So for example, we've implemented this on the front page of our demonstrator, on the front page of musicbrands.fluidops.net. If you, for example, we have here the top 10 Beatles releases according to the sum of track durations. And if you click on that widget auto-suggestion link here, what you will end up with is basically you get the query result as a table. Yeah, so nothing really happened here. But on the left side of the page, you have here all these visualization options that the system auto suggests for you. So for example, you can choose the bar chart here and end up with that kind of visualization, which is directly generated from you then. Yeah. So yeah, this is quite a powerful capability if you want to experiment with a little bit with different forms of visualizations. There are also other tools out there that do visualizations of linked data, or in this case, especially of linked open data, like, for example, LOT-Live or LOT visualization. So LOT-Live basically uses graph representations, where LOT visualizations, on the other hand, uses tree maps to display hierarchical information. In the webinar for chapter 3, for Euclid chapter 3, Barry talked about how this picture on the linked open data cloud was generated. So the bottom line is that this picture was generated by hand, and but there are also tools available which are able to create such a visualization of the LOD cloud automatically. For example, there is GEFIS, where you basically have the same kind of story. You have in the central part here, DBpedia, and going out from DBpedia, you have all these data sets there that are related to it. And like in the handcrafted picture, the size of a node here represents the size of a data set. There's also ProtoVis, also auto-generated. The main idea here is that the colors and the intensity of a node in the graph, so the color and intensity of a data set here, reflects user ratings related to the data set. So the more intense a node appears to you, the higher and the better ratings that data set got. Let's talk also a little bit about linked data reporting. So the idea is that we use visualization techniques to create simple or more complex dashboards of analyses that you are interested in about your data. And there are several tools out there that allow for easy creation of such dashboards over your data. Like, for example, our information workbench, which is directly targeted for all kinds of linked data. But we also have the eCloud Manager, which is a special solution, especially targeted concerning the data center domain. So you have all kinds of dashboards related to data centers and cloud management. In the following 2 or 3 slides, I'm going to show you a little bit the Google Webmaster tools, which easily allow you to get some overview of the structured data available on a specific website, on your website. These structured data dashboards that Google offers are available on 3 levels. So there is the site level view, which basically aggregates the structured data available on your complete website. Then you can narrow this down to the item type level view, which basically provides details per page for each type of resource. That means each class available. And then there's the page level view that shows the structured data available only on a specific page. For example, this is yeah, this is an example of the site level view, where you can see the amount of structured data on this site evolving over time. And at the bottom, you can, for example, see that you have over 2.5 million instances of the class book available in your website. Yeah. And then navigating to a specific page, for example, so the page of an imaginary product 1, you can see that this page is typed as product, has a certain image available with a specific name and a description. And yeah, so for this specific web page, this is all the structured data available in the page. So that was it from my side.